So there are different kinds of changes that matter can undergo. A physical change alters the state or the appearance of the matter, but doesn't change its composition. So the example given here is water that's boiling. So here in the liquid we have these little water molecules. They look like little Mickey Mouse heads to me. So these little water molecules in here, and it's a liquid. When we heat that pot of water and it boils, the water turns into steam, water in the gas state, and now the particles are farther apart from each other, but the individual particles are still the same thing. It's still water, it's just changed its physical state. So we call this a physical change because the essence of the substance hasn't changed. So anytime you have a change in state, solid to liquid, liquid to gas, etc., that's a physical change. Take a piece of wood and you cut it in half. Each of those two pieces is still wood, right? They're different because they're shorter now, right? But it's still wood. That would be a physical change. In a chemical change, the actual composition of the matter changes. So the example here is a nail that's rusting. So here we have an iron nail. Here we've got an illustration of the iron atoms inside that nail, and they're arranged in a very particular way, and it's just iron atoms. When this nail rusts, it combines with oxygen to form iron oxide. The composition of the substance has changed. It's not just iron atoms anymore. Now it has iron and oxygen. And this will typically change a lot of the physical characteristics of the matter as well. But this is a chemical change because the composition is different. So here are some more examples. That kind of looks like an iceberg, but it's actually a big chunk of dry ice in an iron ring. So dry ice is solid carbon dioxide. And you let that sit there. It's individual carbon dioxide molecules that are frozen, stuck together. You let that sit there and it will sublime. Dry ice doesn't melt. If it melted, it would get wet. It would be a liquid, and then it wouldn't be dry ice. Wet ice is regular water. It melts and gets things wet. Dry ice goes directly from a solid to a gas. So what's happening here is the solid particles are separating and going into the gas state. But the individual particles are the same. So the gas around this, the CO2, is the same pieces as in the solid dry ice. That is a physical change. Remember taking some sugar and putting it into some water. You stir it up. What happens? Well, the sugar will dissolve, right? And then you look at it and it's like, well, it looks like the sugar disappeared, right? I can't see it anymore. But if you taste the water, you can tell that the sugar is in there, right? So a solid just dissolving in water is also a physical change. Here we have the sugar molecules in the solid sugar. When those dissolve in the water, they separate from each other, but the individual particles are still the same. It's not necessarily something that you could observe. You can't know just by looking at it that these are still the same particles, but I'm telling you about it now. When something just dissolves in water, all that happens is the particles separate. It's a physical change. The individual particles are not changed. Here we have propane burning. So here's a little burner attached to a small propane tank. So here are propane molecules, and in the combustion that happens here, in the burning, these propane molecules combine with oxygen from the air and are changed into carbon dioxide molecules and water molecules. These are both in the gas state, and so they float away. They're colorless. We can't see them, and so it looks like the gas is just disappearing. We also get a lot of heat that comes off and some light as well. So we started with these particles, we end with those particles. That's a chemical change. The particles are different. Any questions? So those were changes. We can also refer to properties as chemical or physical. So a physical property is one that you can observe or demonstrate without changing the composition of the object, of the substance. So the smell of gasoline is an example of a physical property. When you smell gasoline, that does not change what the gasoline is. The taste of sugar, the color of the wall, the boiling point of something, its density. You can measure or observe those things without destroying the substance. Those are physical properties. Chemical properties are properties that can be displayed or observed only by changing the composition. So these are all going to be descriptions of essentially chemical reactions. So the flammability of gasoline. Gasoline is flammable. When you demonstrate that property, though, you burn the gasoline, you don't have gasoline anymore. It burns up. Corrosiveness, acidity, toxicity, these are all examples of chemical properties. So iron rusts. If we demonstrate the rusting of iron, we've destroyed the iron. It's not iron anymore, now it becomes iron oxide. That's a chemical change. So the description of that is the chemical property. So here's a little check on our understanding. Determine whether each change is physical or chemical, and what kind of property is demonstrated in each case. So a copper wire is hammered flat. Is that a physical change or a chemical change? It's a physical change. It's still copper, right? We just changed the shape of it. So that's going to be a physical change. And we could identify that property, that copper wire can be hammered flat. We could state that as a property. That's also known as malleability. It's a common characteristic of metals. Would that be a physical property or a chemical property? A physical property. Let's look at B. A nickel dissolves in acid to form a blue-green solution. So this one can be a little trickier. So it says that it dissolves, but nickel here, we actually mean the coin. A nickel dissolves in acid. And it's forming a blue-green solution. So what's your best guess? That's going to be a chemical change. Clues here are the words to form and that we have a color change. Color change is not always an indication of a chemical change, but it usually is. So this would be a chemical change. And that property then would also be a chemical property, that nickel dissolves in acid. Dry ice sublimes without melting. Chemical or physical? Physical. It's still carbon dioxide. It's just changed its state. Anytime you're talking about just something changing, gas, liquid, solid, it's going to be a physical change, and then that's also a physical property. A match ignites when struck on a flint. That's going to be chemical, isn't it? So you demonstrate that property or that change, and what do you have left? Do you have the same match that you started with? No, you can't do it again, right? Because it got changed. The copper wire, you hammer it flat, still copper. The match, you strike it, it burns, Now you don't have the same match left. Some of these are tricky to identify. There will be a couple of questions on the first exam asking you to identify chemical or physical property or change. I will try to make them something that should be obvious to a regular person. Okay.